All right, so hopefully you just finished up the section on art poisoning and sniffing, but now we're gonna kind of round out the whole man in the middle ethos here to show you just how far we can go with this. Now, as you can see on my screen, we've got the art poisoning going still. We've got, de-sniff and stuff like that still running in the background. But what I'm gonna do now is I want you to think about something. We're gonna stop the art poisons. And we're going to do a little bit of, again, what you guys are really like to see me do, which is draw stuff. And what we're going to be looking at here is kind of a process where we're going to look at some more interesting things that we can do here, um, with ourselves being in the middle. So, what I want you to think about is what we've done thus far. We had our two victims. That we had set up like so. And we simply put ourselves in the middle with art poison. And then once we were in the middle with art poison, we had traffic now diverted between these two going like this so that we were essentially able to sniff that traffic. As it went back and forth, we're now sniffing it because we're in between the communication flow. But now it's time to think about some more devious things that we can do with that. Earlier in this course, we got an introduction to DNS cache poisoning. Now, what I'm going to do is show you how to tie that together into more of a chained exploit to make it something more devastating. So we were doing this, but if you can imagine, if this were, let's say, a wireless network, public Wi-Fi like Starbucks or somewhere like that. And this big green cloud over here is representing the internet. So what you would have is you would have, for example, Facebook out on the other side of the internet. So let's draw Facebook out here. And what we talked about in an earlier session with the whole DNS stuff is, Facebook might have a public IP 64.33.67.98. Now, don't go check that. That's not actually Facebook's public IP, but I'm just putting it there as an example. So, what we talked about is, let's say victim one over here, who we've man in the middle successfully. Wanted to go to Facebook. Well, what would happen is there's going to be a DNS server somewhere on the network, probably here, and it's most likely going to be either the router that you're going out over. Let's just draw us a little wireless router here. Isn't that like the most excellent wireless router you've ever seen? So what happens is this victim here would send a query out through this router. And we can get rid of these now. So this victim is sending a query out through the router to basically try to go to Facebook, to say it's going to go to the router in the form of a DNS query that says, where is Facebook? Now the router is either going to be doing DNS itself here, or it's going to pass that query onto the DNS server to ask it, where is Facebook? And that DNS server is going to respond back eventually, like so. And basically tell the victim that Facebook is at 64 33 67 98, like so. If I can get my typing life together here. So it would look like that, basically. And then based on that response, this victim would then go out to that IP across the internet. So that traffic would now look like so. Based on that response, the victim would now go out through this router across other routers that are spread across the internet, and eventually make it across those routers to, guess what, Facebook.com. And as a result of that, it would pull down a copy of Facebook. So Facebook would send it back a copy of its homepage. Back across that same infrastructure once it gets internal. And then magically, the victim now has a Facebook page in their browser. They're looking at Facebook. That happens every time you visit a site. But now that we're in the middle, what if we did the following? If I can get between this victim and this victim, why can't I get between this victim and this router here? Because if we can ARP poison two devices, why can't we ARP poison one computer and one router? Because that router is still a network device. It still understands a protocol the same way that your end device, your computer, understands it. So it should be susceptible to the same thing. So what I would really like to do is, instead of having a man in the middle that puts me between these two, like so, I really want that to be a man in the middle that puts me between, let's just say, one of the victims. We'll go with victim one and the actual gateway, because my end result should look like this. When this person makes a query, and we talked about this a little bit with the DNS caching, but now we're going to kind of do it full-fledged. When that query comes through, what should happen is I should be able to see it, and whether or not it makes it to the real DNS server or not is irrelevant, because even if it does, when the reply comes back, I'm going to intercept it here, modify it, make it say what I want, and then send it on back to the victim. Which means I should be able to, based on our concepts of DNS cache poisoning that we talked about earlier, I should be able to poison this DNS cache to make it go wherever I want it to go for Facebook. In this case, let's say it's my actual IP of 192.168.248.5. I can make it say that and make them come here when they try to go to Facebook. But if I do that, don't I need to go out to actual Facebook, get a copy of Facebook, bring it down so that when they hit my version of it, it looks just like Facebook? So I'll bring that copy down of Facebook, set it here, have the victim visit. They hit my version of Facebook, which now I got them seeing Facebook from my perspective. Well, if I can do that, then I should be able to put some code in my version of Facebook to cause something to happen on my behalf when they load my version of Facebook, right? That's what you can do once you're in the middle. This is one of the advantages of man in the middle. We can do replays and relays. And what we're doing here is we're going to do a replay and a relay on top of each other. The replay is going to be where we take the query and send it on. The relay is where we're going to take it, look at it, manipulate it, and send it on after we've done something to it. All right. So let's look at what this actually looks like when we act it out. So as I said, we need to now poison the gateway and the victim. So I need to, instead of poisoning, these two, I need to tell victim one, which is dot two, that I'm the gateway, and I need to tell the gateway that I am the victim, like so. Now to check that, if we go over to this is our victim one, it is dot two, that's who we're fooling. So I start the poison this way. I start in the opposite direction. Now we're man in the middling the victim and the gateway, or your wireless router, which would be a Starbucks or somewhere. So as a result of that, I can now stand up, create a little host file here that lies and says that Facebook is at this machine's, my Linux machine's IP. Now run DNS spoof, which we looked at earlier in the lesson, pointed at that file. And now what should be happening is when that victim tries to ping Facebook, we should get back that it thinks it's at .5, which is our machine's IP. So let's go check the victim. We ping Facebook. And it indeed thinks Facebook is at .5. But that's not enough, because now we have to go get a copy of Facebook so that when they hit our page, they're seeing something that looks like Facebook and they're not seeing an Apache page or something like that. So in your mind, you might be envisioning, well, we have to go to Facebook, visit that page, do file, do save as, save down a copy of Facebook, then manually edit it to put some code in it. Nope. This is where I'm going to introduce you to something called the Social Engineers Toolkit, or SET. SET can automate all those pieces for you. So let's look at what that looks like. So I'm going to fire up SET, and there's many updates to this. I'm still using a classic, we'll call it a classic version of it here, because it's still the most basic, and I want you to see the fundamental pieces. So I'm in the set. I'm going to go with 1 for social engineering, 2 for website attack vectors. I'm going to go 2 again for browser exploit method. And then I'm going to go 2 for site cloner, no for natting. And what do I want the reverse sessions to come to? That's going to be to my machine. So if you were setting up Metasploit, this would be like your L host. It is actually going to take this and put it into an L host configuration once it launches Metasploit later. And then who do I want to clone? Let's make that Facebook. Then it says, which browser exploit do you want to try to use? I don't know what browser the victim may be using, so I'm going to go with Autopawn. Because what Autopawn does is when your browser hits my fake Facebook server, in your browser, you always connect to a website with a GET request or a POST request. But when you do that GET request, you do that and you send something called a header that tells the web server what your browser and operating system is. The reason you do that is because that web server needs to serve you out the version of the page that's most compatible with your browser and operating system. What we're going to do here with SET, we're going to get that same information from your header, but instead of sending you the perfect version of the page, we're going to send you the perfect exploit for your browser and operating system. This is all built in the SET, and it's all automated. Thanks to Dave Kennedy for creating this. So now what we do is I'm going to go ahead and pick 2, because this is asking us what payload we want to launch. If we're able to exploit, we're going to go ahead with the reverse TCP interpreter session. I want to use port 443 because what this is asking is, look, if you exploit that victim's browser, they're going to connect back to you with a Meterpreter session. What port do you want that session to come out over or connect to? I'm going to stick with 443 because number one, the Meterpreter session is encrypted. So if you think about your network and your IDS and the people that would be inspecting, they're used to seeing encrypted traffic come outbound over to 443. So I'm going to stick with 443 so that encrypted Meterpreter session that I'm going to try to make this victim send me back goes over 443, and it blends in with all the other encrypted traffic. So we're going to leave it 443. It goes out to the real Facebook, clones the actual Facebook page as it is right now. Now it injects the malicious iframes, the malicious ActiveX objects, the malicious Adobe plugins, all these malicious pieces of code. It's putting that, packing it into that Facebook page on its own. I don't have to manually do that. And this is the brilliance of SET, or the Social Engineers Toolkit. Now, once it's finished building, because what it's doing now is it's putting, I talked to you about how it's going to take and send you the appropriate and most useful exploit for your browser and OS. It's loading all those in SET and in Metasploit so that when you hit it, it can send you to the right one. So now we're going to go and play the victim and simply try to go to Facebook. So we go to the victim opens their browser. Victim decides to try to go to Facebook. Starts loading. We come back over and look on the attacker side. As a result of that, right there, we now have control of that victim's machine. Now, we don't have elevated privileges, but we do have a session. So we can connect to that session. All right. If I want, I can now take a screenshot and prove that we now have control of that victim's machine, because at the very least we can take a screenshot and see what's on their screen. For example, if they left that and went to their bank account or something, let's say they go here to their Chase bank account. Well, we can see that. To prove it, let's take another screenshot. We see Chase, so we see what they see on their screen. And just as importantly, we can do things now like run keylog recorders. As a result of this, what happens now is we can record keystrokes. So let's say this victim decided to log into their Chase account. So I'm going to log in here. And of course, I'm not going to log in and give you my real Chase password, but I did attempt to log in, so I sent credentials. But what did we get on the attacker side? Well, if we come over here and stop the keystroke recorder, now we go and grab this file. Remember, all of this is being translated and recorded locally to the attacker's device now. If I grab this and now try to read it, I'll just use more to read it, something you'll all have on your terminals. And sure enough, I can see where we sent Keytron as our login, and I sent not really my password as the password to log into that Chase site. So we're truly grabbing keystrokes and everything else here, and we haven't even elevated into any privileges yet to a higher privilege. Now, we could do privilege escalation from here, but that'll be a later session that we'll get into some privilege escalation stuff. But this is kind of the pinnacle of man in the middle. This is some of the stuff you can do once you're in the middle. Just to review, thinking back on the last 3 lessons, we did ARP spoofing. ARP spoofing is what put us in a position to where we could be in the middle. So ARP spoofing, ARP poisoning, whatever you want to call it. So we did ARP spoofing to poison both sides' ARP caches, got ourselves in the middle. Then as a result of that, we're able to sniff. Now that we can sniff traffic between any 2 devices, or any devices we want actually, we can sniff things like credentials. We saw that with the FTP session. We can sniff things like DNS queries. In other words, we can see where a person's trying to go before they get there. And as a result of us seeing that, we can kind of jump in front of it and send them off somewhere that we want them to go instead of them getting to the actual website they were trying to go to. That is the DNS cache poisoning that we touched on a little bit earlier in a session, but I wanted you to see how it all ties together. And when we think man in the middle, these are the kinds of things that we can think about. And if you want to really have a defensive lesson here that you can give to your colleagues or friends or family members that are not very technical, this is a perfect reason to not use public Wi-Fi if you don't absolutely have to, because there's nothing you can do really to stop this. Even VPNs don't actually help you. There's other twists on this technique that I can show you to where VPNs, I'm actually, praying that you open a VPN connection, because now you've put me on your internal network based on me dropping some code on your box as soon as I get in. And even if you disconnect me, that code is there. And when you open that VPN, that code is on your box. It's going to jump across to the internal network. Okay. So hopefully this opened your mind up a little bit and made you think differently about man in the middle, give you some other possibilities of where you could go with it, and just see how devastating it is. Looking forward to seeing you in the next session, and we'll see you then. Thanks for watching.